Hi, everyone, and welcome to today's SQL Office Hour session. Today, we're going to be looking at some of the things that are here in the new latest release of Oracle Database 23.9. And to start off with, I'm actually going to jump straight into a demo, a little example of the kind of problem that many of you will have encountered. I've certainly encountered this kind of problem a lot in my career. So we've got an insert statement here, and there's a problem with it. But just by looking at it, it's not immediately apparent what the problem is. It's like, it looks okay. The syntax looks fine. Certainly, if I run it, it inserts a row. There's no errors there. But I've made a mistake in it somewhere. And just by kind of glancing over, it's not immediately apparent. It is easier to see if we actually query the data. And actually, in this case, it may still be a little bit tricky to see. We've got a first name of capital Squirrel, last name Sally, and an email of Squirrel. Unfortunately, I've mixed the names and the email up. It should be first name Sally, last name Squirrel, and the email of Squirrel, right? So this is the kind of thing that it's really easy to do with insert statements, is accidentally put the values in the wrong column. And if you're lucky, if there's a lucky in inverted quotes, you'll get some kind of data type conversion error. You'll be alerted that something's going wrong. But if you're unlucky like this, the values will just go in, and you won't know until some point later someone queries the data and goes, well, hang on, this doesn't look right. There's a problem here, right? So let's just roll that back. So the question is, how can we solve this, or how can we address this? Well, there's one way we could do it, and that is to kind of align the columns with the values. We've got look up here. Part of the problem is that the values for the columns are not kind of next to each other. They're kind of far away, so it's easy to make a mistake where you put something in the wrong column. So one way we could address that is just try and align everything like this. So we put the value directly below the column. And this kind of does the job, right? We can now see everything and hopefully it lines up. But it's also kind of impractical, right? I've only got like 6 columns here, and already it basically fills the screen, right? There's, I don't know, there's more columns than this in the table. I haven't supplied value for every column. We do that, it's kind of going way off the screen, and we have to do scrolling backwards, left and right. And, if any of these text values are long descriptions or something, it gets really, really impractical to do this. So this can work in limited scenarios, but generally speaking, it just kind of moves the problem around a bit, right? Now, of course, some of you are going, well, I should do the right thing and use bind variables, and maybe give them better names than V1, V2, and so on. But that problem still exists then. We might accidentally bind something to the wrong value or something like that. So how can we address this, or how can we make it less likely we're going to accidentally screw up and stick a value in the wrong column? Well, and the solution here is basically bring the values in the columns next to each other or closer together. And this is something we've been able to do for a long time with PL/SQL record inserts. So I can declare a record of the table %row type. So that has all the visible columns from the table. And now we can see we've got all the values kind of next to the attributes. So if I make a mistake, it's much easier for us to see, oh, okay, I've stuck something in the wrong column. It's not impossible, of course. I might still accidentally screw up, but it is easier to spot, particularly if we've got like 20, 30, 50 columns and values that we're supplying. So we can do that. That sticks the value in. And we can see we've got Sally Squirrel, email Squirrel, right? So that has worked as we would have expected there. So this does the job, but there's some limitations with it. First up, well, the main thing is, if you might listen to what I said carefully, it supplies the values for all the visible columns. So let's try and add something we cannot supply a value for, and that is a virtual column. So we're generating the full name as, the first name concatenated with the last name. If we add that, this is generated by the database, so we can't put a value in it. But this %row type tries to supply a value for every single one of those columns. We'll run it. So we're going to get an error, insert operation disallowed, right? We can't do that because we got a virtual column here. So let's just remove that, clean that up a bit. As I said, I mentioned visible columns as well. Let's make email, for example, invisible. That means it's hidden from generic table access. So our %row type no longer actually has the column or attribute email in it, right? So I've tried to assign email here. It's a column in the table, but this %row type cannot see it. So I run it and it goes, oh, what's this email thing you're talking about? It doesn't exist. I don't know what you're talking about. Okay. So these record types, they're pretty cool, right? But if you've got virtual columns, hidden columns, that kind of thing, they are a bit impractical. There are workarounds for this, maybe a talk for another day, but it just can get a little bit fiddly, right? And of course, if as we change the table, this could accidentally break things in the future, as we saw. If we added that virtual column, suddenly we've broken this insert here. Okay, so this is one way to address it, but it has some limitations. Now, if we think about other statements in the database, notably update, where we supplied values, we don't have this problem with update, right? We've got the column, we've got the value. They're right next to each other. So we're very unlikely, or I say very unlikely, we're less likely to make a mistake. And if we do, it is easier to spot because we can see, okay, higher date should be a date or something like that. So this kind of mismatch, or you've got your columns up here and your values down here and you can't see how they relate to each other, isn't a problem for update. So the question we kind of had here at Oracle is like, well, why don't we make insert look more like update, right? Why don't we do this? Okay. And so this is kind of showing you that's exactly what we've done. So we've made numerous improvements actually to the insert statement. So we'll run through those, and we'll also look at some other stuff that came in the latest patch for Oracle Database 23.9. So hi everyone, I'm Chris Saxon. I'm part of Gerald Wenzel's app dev team here at Oracle Database in the PM organization. I'm here to help you get the best out of Oracle Database and hopefully have some fun whilst doing so. Thinking about fun or ways to test your knowledge of SQL, Oracle SQL specifically, over on Oracle DevGem, we've got numerous quizzes to help you practice your skills. We've got some kind of more lightweight quizzes, such as speed SQL. So every day there is a set of 10 SQL statements. You've got to guess the missing keyword. So we've got something, 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 max, and you've got to pick whether it's sort, compress, select, or unused. Hopefully all of you can figure out which is the missing keyword from this one. But the interesting thing is you've only got 60 seconds. So you've got 1 minute, you've got to guess the missing keyword from all of them. You can play as many times as you like. Every day we'll release a new batch of 10 statements for you to guess. So you can come back, and just a good way to learn and practice your Oracle SQL syntax knowledge. Another way, we've got Squizzle, our Guess a SQL Statement quiz. So we'll have a part of a SQL statement up in the kind of top right and SQL fragments below it. You can think of it as a bit like SQL Wordle. So you got 6 tries to guess what the statement is, complete it, see if you can guess how it all works. So like I say, they're nice little lightweight ways you can use to help you learn SQL, practice your SQL skills. I personally like the game Wordle and things like that. So if you like those kind of games, you can play it on your phone and stuff. Getting back to what we're talking about today, I'm going to be running lots of demos, and they're all going to be running on Oracle all going to be running on Oracle Autonomous Database on the free tier. So this is free for you to use kind of whatever you want to do. This was patched automatically up to 23.9 when it came out a couple of months ago. I didn't have to do anything. I just logged in the next day and magically it was all upgraded for me. So I'm going to run all the demos on this. So great way to kind of, when you want to try things out, learn how it works, and see how the latest and greatest in Oracle Database works. All right. Enough of that. Let's get back to what we're actually talking about. These new insert statements. So like I said, we thought, well, we've got update where we've got the columns and values next to each other. Why don't we make insert look like that? So that's exactly what we've done, right? Notice it looks almost exactly like an update statement. We've got insert into table and then set column value, column value, column value, and so on and so forth. So this is great when you've got single or multi-row inserts, when we've got lists of values we want to put in, basically. There is, however, another form of insert, which is reasonably common as well, and that is insert select. So inserting the result of a query. And again, this is subject to the problem. You've got your insert column list here, and you've got your select list down here. And how do you make sure they match up properly? Well, we've added the by name clause, which does name-based matching for these. So rather than kind of, they say, show you a whole bunch of slides, I'm going to show a demo of these in action. Right, so let's get going. Start off with what's going on. So first question, I see someone's come and asked, is this going to be part of the ISO standards? We plan to. There's discussions going on, but I don't know when the next version of the standard will be out. It'll be at least another couple of years. Who knows, right? But we do plan to put it in the standard as well. So yeah, it's ongoing. Stay tuned. Obviously, I don't know. I'm only very arm's length involved in that, but we hope to. Okay. All right. So, like I say, we've got the insert set statement, and just to show it works, there we go. In it goes. We've added the row, and now we can see we've got the columns lined up properly. So let's just back that out. Okay, so we can do that if we're just adding one row, but what about multi-row inserts? So in 23, in the base release of 23 AI, we added multi-row inserts. So something I didn't know is this values, it's actually a row constructor. So essentially generates a row on the fly. We can have a comma separated list of these to add many rows in one go. So we added this in 23 II, we get 3 rows in. So how does that work with this new set clause? Well, basically we have set, and then you wrap each row in brackets. So we put brackets around, and then we just put column value within those. So it looks a bit like the single row, just each of them wrapped in those kind of parentheses. So I'll put that in. We'll see that actually. I've run that twice. I had both of them. So we get 3 rows inserted. There's our 3 people we've just added there. We can roll that back. So one of the nice things that this then does is it also enhances the functionality for these multi-row inserts a bit. So just go back up here. We've got 3 rows. What happens if we only want to supply values for some of these? Well, you kind of can't, right? If we don't know someone's email, for example, or their hire date or whatever, we'd have to explicitly put null for the values we don't know. With the values clause, we don't need to provide a value for every column for every single row, as long as it's, nullable, right? It's, suitable constraints, not null constraints permitting. So notice we're only actually providing values for 4 of the columns in this bottom row here, whereas the other 2 we're giving 6 values. This is perfectly permitted. Another little interesting detail is we now no longer need to make the order of these columns match. I can put employee ID first in that first row and then 4th in the second row. Okay, so there's no longer this requirement that the columns match in order, or the number of the columns match order. I'm losing the ability to speak here. The order of the columns in each row can be different, and we can omit some of the columns from some of the rows, should we wish to do so. Okay, so we can put those 3 rows in there like that. Now, at this point, you kind of go, well, that's nice, but I don't want to do that, right? I don't want to let that happen. That's kind of nuts. I don't want to stop people to accidentally miss some values out here. Well, you can still provide the column list at the start, like you would with the insert statement today. And then this becomes a rigorous column list. So that means we need to provide a value for every single column listed up here. So we notice like job ID, and which one is it? Which one I missed off? There we go. Employee ID. I haven't assigned an employee ID for the final row. So this is going to fail. It goes, you've got an error. You've missed one off the list. And we can't have an extra column either as well. We can't have too many. We have to match exactly. However, so this becomes a rigorous list. It also does have the advantage, again, if we've got like 50 columns or something, and we just want to see what those columns are, having one list to see, one place at the top to see them all can still be useful just to help you kind of understand the statement, right? So they've all got to match this exactly if we've listed. However, you can still put the values in any order you want, right? Wow, crazy, right? So notice I've put first name first in the insert list, the target list at the top, but it's fourth for the first row and then first for the second row. So as long as we put all the columns up here in each of these rows, it doesn't matter which order they are within the rows, so we can mix up those. Which again could be useful in certain circumstances if you're kind of constructing things on the fly and stuff like that. So you can see both of those rows do actually go in, even though we've changed the order of the columns in the set clause. All right. One other thing we can do is set use parentheses to actually set a list of values. So we can do something like this. So we can assign things like that. One of the things that allows you to do is essentially have groups of columns that you assign. So you can see we got the employee hire date job ID as one group, and the name parts and the email as another group. So that works, right? That goes in like that. Now at this point, you might think to yourself, well, what's the point of this, right? Why would I do this? Okay, it seems a bit, I don't know, superfluous or whatever. Well, there is a couple of reasons. One is it can just help logically grouping things together. You know, let's say we want to have all the name related columns together. That might be useful too. You might find it handy. However, there is another advantage as well. Let's say these values actually come from another table. So we want to insert data from another table, but not just one table. We've got 2 or 3 tables that we want to insert values from, and there's no kind of like common join between those tables. Let's look at another example. We've got job history. We want to take the current employee information for some of these columns, and then we just want to set the department to administration for, I don't know, some reorg or something. Maybe we're saying everyone's in administration. We're not joining employees to departments because we're not trying to find their current department. We just want to say everyone is in admin. Okay, so we've got 2 independent queries here, and we want to assign them both in one insert statement. That was a bit of a pain to do in the past, right? Particularly when we've got multiple columns like this. Do you repeat the column, have lots of scalar subqueries repeating this table? It's a bit of a pain, unnecessary work, things like that. Do you kind of cross join these together? That's not great either. There's lots of little details. By having these kind of column groups, we can assign them separately. Okay, so notice, as I say, this must return one row. These must be scalar subqueries. If I just kind of comment that out, you know, the single row subquery must return one row. Okay, so it's useful just logically grouping columns, but very useful if you've got independent queries that you want to assign values to. This is a question: how does it distinguish between 2 groups of columns for the same row versus 2 different sets of columns for 2 separate rows? I mean, I guess you mean what, like this duplicate? If we duplicated like this, come on, if we copy that and like have 2 of these, you mean? If you mean how do we duplicate like this? Well, we're literally repeating the whole statement, all the columns again for both of them, right? So we can do things like that. How does it do 2 groups of columns for the same row versus 2 sets of columns for 2 separate rows? I'm not sure what you mean, right? These can be different for every single row, okay? Each row is its own thing. If you mean, can we remove job ID or something like that? We can do that as well, right? It won't work because it won't accept nulls, but logically, this is allowed. These are entirely independent rows. You can do whatever you want there, right? So I'm not really sure what you're asking. So person raising your hand, put the question in the Q&A, right? And I will answer it. Put all questions go in Q&A, okay? Okay, so yeah, right. I don't know what your question is. Right? That's what I don't understand the question. It's two groups of columns. Yeah, but how does it distinguish between two groups of columns to the same row versus, right? There's brackets around them. Look, there's brackets. So this is one row, right? There has to be brackets. I okay. You have to have the parentheses. That's how it knows it's a row. Every row is it's got the parentheses around it. Okay. Um, is that okay? So anyway, let's move on. So again, this row has parentheses around it, and then each column group within it has parentheses around it. Okay. Side note, this kind of column grouping also now applies to updates. Okay. So this is something that you couldn't do an update before. Again, if we wanted to have, we had independent subqueries to assign values to, it was a bit of a pain, right? Or it could be a bit of a pain. Okay. So we can also use this syntax with um, um, update two. Alrighty then. So we kind of one of the problems we looked at with the record-based insert is if we added virtual columns or made something invisible, it broke. Okay. And if we did this with our a regular insert, now I've been a bit naughty here. Maybe I probably should have listed the columns out. They would have been fine. But it's literally the point here is it's using this column-based insert. It's impossible for this to break because you've listed all the columns out, right? The fact that email is invisible doesn't matter. And the fact we've got a virtual column again is irrelevant because we haven't listed there at all. So neither of these are things that can catch you out if you use this kind of set insert or non-positional inserts, as we call it. All right. So yeah, is there any other questions or comments on that? Just they say put them in the Q&A and I'll pick them up. Another thing we looked at was showed in the slide was inserting a query. Okay, so again, there's a problem here, but it's even less obvious because I've been naughty and haven't actually listed the target columns here. We'll run it and it's like non-numeric character found. What does that mean? Why have I got that error? Well, it's because I've assigned one of these date columns, date values is going in a non-date column, essentially. Okay. And the implied column list is just the list they are in the table is different to the select list here. That's a bit of a pain. So now we have name-based matching. Okay. So we can run this now. We use by name and voila, it automatically works. Okay. Because the names of the column of the aliases in the select here, the database matches those to the columns in the insert statement and you're done, right? As long as these actually match up. Okay. Now, thing here is the name matching. It's done either by column name. So this value has to be a column from the source table or tables, or it has to be aliased. So sysdate is a function. So it won't try and match sysdate to a column called sysmate, and it won't even allow us to do this. It says non-aliased expressions are not allowed. So if you happen to have a function which matches the name of a column in job history, it won't help you, right? You've still actually got to supply an alias for it for it to be resolved correctly. Okay. And this name alias matching, it ignores, or this name matching, it ignores any table alias you supply for the source table. Because of course, if we've got a join here and several tables listed, we might want to alias them to make it clear where they're coming from. So again, this works because the alias, it's not the alias that matters, the table alias, I should say. Be careful, right? The table alias is just ignored. It's the column name or the column alias that is used for that matching. Right. And again, like with the set insert, we can provide a column list here. So what have I done? I've not in, yeah, we can do that. So as long these then have to match exactly. If I miss off job ID, it will tell us, it'll give us an error that there's a mismatch there. Okay. So again, useful if you want to be rigorous or and just have an easy way to see what all the columns are. Okay. But they don't have to match by order. Like say, employee ID's first here, but it's fourth in my third, in my select list. So the order is irrelevant. They just all need to be present, and only those present. Okay. And yeah, there's a question if the column name. So notice I'm aliasing the hire date column from employees to start date in the target table. So if the source table doesn't match a name in the target table, which is pretty common, right? You just alias it to resolve that. And just kind of cover off, by name is new syntax. We also have by position. This is the behavior you have today, okay? Or the behavior you had before 23.9, whatever you did. So this is the default. There is an implied by position clause from 23.9 onwards. And that does, they say, positional matching, and it implicitly assumes they all line up correctly. Yeah, final thing on this. The by name / position clause is only for insert select, right? So we've got insert select, insert set. You can't have by name or position, which I guess, kind of makes sense, at least to me. They kind of do slightly different things. So you can't kind of combine these things there. Alrighty then. So that was a quick tour of what's new here. Any more questions or comments before we move on? No, I'm not seeing anything else at the moment. So they say, feel free to put questions in. If you're typing away, I'll pick it up. So someone's questioned backport. Just general point on backport. If you want backports, you raise it with support, okay? And there's no promises on when things or how likely things are, but if you don't raise it with support, it won't happen. Let's put it that way. Okay. So but yeah, I still think backports are unlikely, right? But okay. So quick recap on those non-positional row inserts. So you could insert a PL SQL record with the values and stick it in. This is kind of nice and has been around for a very long time. I don't know when this was added. A very, very long time. Let's just put it that way. The drawback, well, I guess there's a couple of drawbacks. One is the PL SQL block is just a bit more code, but it's always going to assign values to all visible columns in the table if we just do % row type. Okay, so you might run into issues with virtual columns and things like that. 23.9, we added the set clause. So we can use this to set any columns, and it's single or multi-row. If you've got multi-row, you need the parentheses and then comma separate them. And we can also use subquery for non-positional name matching. So we do insert by name. Okay. So that covers off probably the most common of the vast majority of insert statements that you would write. However, there are some other forms of inserts that you might write. For example, merge, right? You can insert rows with a merge statement. Well, what about that? Does that work? Well, the answer is yes, right? So this syntax is also supported for merge. So this is just the insert set clause, not by name. Again, I'm not sure it makes sense for merge. Also, some of you might know, and someone has already foreshadowed this or predicted this, it also works for multi-table inserts as well. So this is where you can have one statement that inserts into more than one table at a time. So where we've got insert all, and we can insert the results for query into many tables at once. So both of these support this new insert set syntax. Okay. So let's look at those in a bit more detail. Okay. Oh, excuse me. So with merge, so we've got merge for, upsert logic, insert if not exists, update if exists. And we can see if we've not matched. So we're trying to merge people into their job history. If they're not matched, we can use this new set clause, insert there, and there we go, and that will run it. And that just works. We can also, like with a regular insert, we can supply a rigorous column list here as well to make sure we don't accidentally miss something off or just give us a clear list of what's going on. One little detail is we do need to, or you do need to actually alias the columns for the target table. So we're loading into job history J, you still need to apply that, use that alias or reference the target table, essentially that it knows what they are. If I just delete that, you'll see it gives me a bit of an error. Okay, so we need to prefix the columns that we're supplying here in that column, the target list, with the target table alias or name. Even when we're doing this, we can't just leave them unnamed. So the database can resolve it. Just back those out. Let's look at in multi-table inserts. So again, multi-table inserts have been around for a very, very long time. Okay, a long, long time. Don't ask me which version they are added. I don't know. I'll just say a long time. And we can use this to load the result of a query into more than one table at once. So insert all just says insert this row that we've selected here into both the employees and the job history table at the same time in one statement. And these both, and again, we can use the insert set clause there. So we can put that 2 rows inserted. So we've done one statement, loaded both of them at one go. Now, one thing to note on this is if we're doing insert all, the kind of multi-row insert. So we want to, I'm not sure where we do it this in situation, but there might be situations where you want to load one row twice into the target table. We can't use insert select or insert set with multiple rows like this. Okay, this will give us an error. Tells you it doesn't work. You're like, I want to do that, right? I want duplicate employee rows. Okay, I'm not sure you do, but maybe there may be some scenarios where you do want to do something like this. The solution here is actually pretty easy. We can list the same table multiple times, right? We can just keep listing the table many, many times. So we can see that gives 3 rows. So we've kind of duplicated the employee row there and also load it into job history and so on. So let's say insert multi-row inserts. It's a pretty neat feature. It's been around for quite a while. And this is actually how you do, the table values constructor multi-row inserts in the past, or one way you could do it. This also supports all this syntax. If the select returns multiple rows, then each row from here will get loaded into all of these tables. So if we, if I connect by dual it to duplicate 2, so we get 2 rows, we get 6 rows. So each row that this generates will go into all of these tables. Okay, so we get lots of copies of them. There is also, you can do conditional inserts as well. So we can say it goes into these when specific criteria is reached. Again, that's existing functionality. It's been around for a long time. The key point here is the set clause now also works for this non-positional insert. All right. Let's move on and look at some other things. So there are some other clauses for insert. One is like error logging. So if we create some error log tables, if there's any problems with our insert, we can capture, instead of having the database throw an exception, we can log those errors and capture them into our job history, our error log table. Okay, so notice I've got end date of junk, which is obviously not a date. So there's going to be a bit of a problem trying to insert that into a date column, right? Normally if I let's do that, notice we'll get an exception, right? The database, I can't do that. With log errors, we can store all that information in the job history table, and this reject will stop it throwing an exception as well. So this is useful for kind of batch processes, things like that, where you need it to keep going and figure out any errors later on, like in an exception queue. So in this case, everything errors, and our job history is full of all the problems that we got there. Okay. So it supports, we can use by name with error logging. You'll also use the returning clause. So quite often things like IDs, created dates, and things like that are generated. So this will be a sequence generated value quite often. Higher date might even be sys date, something like that. We can use the returning clause to capture those values, and so we know what they are. Okay, and again, this supports that as well. Let me run that, and we can see what's going on. Something I need to. I don't know. What have I done? Oh, it's thinking at me. There we go. There we go. That was why I actually run the statement, wasn't it? There we go. It's um, so it would return that into a. Sorry, here's the example I wanted to run. There we go. Here's the example I wanted to run. So I've got my variable. I'm going to capture the employee ID. That was to show that we got the error, we captured the invalid data, and this is to show that when it works, we can capture values from the columns we're inserting. So we've got that, and this value was put in the bind variable. Again, you wouldn't really use it when we're hard coding. Usually we'd use this because this is a sequence or something like that, or a function, something where we don't actually know what the value is going to be. All right. Any questions or comments on those before we move on? No. So let's just kind of recap on those. So non-positional inserts. We saw the most common things like regular insert in single row, insert select. All forms of insert support this new syntax. So that includes merge. We can use insert select. Again, we can only merge one row at a time. We can't duplicate that. Multi-table, again, we can only do one row at a time in each into. If you do need to duplicate it, you can just duplicate, copy paste the whole thing, right? So it is possible, but each into statement can only load one row. And it supports all the kind of standard clauses for insert that have been around forever, like log errors and return into, and so on and so forth. Alrighty, so I'm not seeing any other questions at the moment. So let's look at what else is in 23.9. So like I say, there's quite a few other things that have been added, some other neat kind of developer features. First up, we've got group by all, which we can use to auto-generate the group clause. There is a new UUID, unique ID generator function, and there's some tweaks or enhancements to JavaScript in the database. So again, let's just kind of look at these action. So to start off with group by, got a query here, and like I say, there is a problem with this statement. What's the problem with this statement? Well, let's look at it. Let's run it, and we can see, okay. Problem here is higher date must appear in the group by clause or be used in an aggregate function. Okay, so I've got higher date here. Trunk is not an aggregate function. It's a single row function, and higher date is in that, and it's not in the group by. We've got an error. So we've got, 23 AI, we've got better error message. Instead of just like, not a group by, you're actually told which column it is. All right then. So let's fix it. We just need to stick higher date in the group by, right? We can just stick it in there, right? So let's run that, and statement works. All must be good, right? It compiles, everything's fine. But actually, when we start to look at the data, we'll see there is still probably a problem here. Notice we got 5 IT programmers, 2016, 1st of Jan 2016, 2017, 2016, 2017. Okay. We've duplicated some of these rows. Okay. And it's like, why? What's going on? Well, grouping happens before selection. So we're grouping by the job ID and the higher date. Then we're running this to find which year, the start of the year it is. Okay. So we do this grouping by the day, then return the year, which leads to these kind of duplicated values, which is a bit kind of unintuitive or not what you would expect with group by queries usually, right? So how can we get around this? Well, in 23 AI, we added the ability to group by alias. So we've got this year alias here. Let's say group by happens before trunk. So rather than putting hire date in the group by, we can put group by year. So if we've got any formatting and so on of these columns, we can, instead of having to copy paste it and worry about making mistakes or um, some unintended mismatch, we can use the alias in the group by. We now know they're identical. And we can see instead of the 5 programmers, we just get 3 and we get 2, two for 2016 and 2017, which is probably what you would expect it to do. Okay. So this is added in the initial release of 23 AI. So this is this is nice. This is already pretty cool. But they say, what if we've got loads? I've only got 2 expressions in the select here. What we've got like tons of expressions. We've got 20 or 30 of these, and they've all got some kind of formatting on and so on. Sure, you can duplicate the alias. It's nice, but wouldn't it be nicer if we could just get the whole thing, right? Well, this is where group by all comes in. It automatically looks at the columns you've selected. And here, this is on the alias, right? So it's not the column hire date. It's saying, okay, we've got the column job ID and the alias year. So it's already taking the result of this and it auto generates that group by clause for us. So like I say, if you've got loads of columns here, and particularly ones with lots of complicated formatting or expressions and things like that, very quickly generates the whole thing for us. Now, you do need to be a little bit careful with this kind of group by all because it might change results on you slightly unexpectedly because it's an auto generator. Good example is if we're doing something like this, select star. So all the columns of this row subquery, that's department ID. That's department ID is the only column in the subquery. So that is the only column in the output. If I comment back in job ID and run it again, notice, let's comment it out again. Let's go back. We've got 1 row for department 90 and it's returning 3. If we comment it back in, we've now got an extra column in our results and we've got 2 rows for department 90. Okay. So, you might go, oh, select star is bad practice anyway. You're probably right. But particularly with group by all, this can magnify it even further because not only are we potentially adding columns to our results, we're potentially adding rows to our results as well. So this is something you probably want to be a bit just a bit wary of to make sure you're not kind of inadvertently or unexpectedly adding these things in. So comment, group by all is the best new thing for many years. All right, wow, that's high praise, right? Personally, I actually think insert set and insert by name is probably better. I mean, but yeah, it's good to see you enjoy that. Right, you like this. So yeah, just be a bit kind of careful with this, okay, because it might unexpectedly change results. Okay. The other thing to be aware of is it doesn't work with group cube roll up grouping sets and so on. So those of you who don't know, roll up, these produce what we call the super aggregates. Okay, so the total, subtotals, and grand total. So what we want here is we want the count for each department, but we also want the grand total, the overall total of all the departments. You can't roll up or cube by all. This will not work. Okay. If you want to do these roll-ups, cubes, grouping sets to get the subtotals and overall total, you still actually need to list them out explicitly. Okay, so just be aware of that as well. So here you can see we've got all the departments. There is an employee not assigned to a department, poor lonely person, and the null here is actually the overall grand total. Okay, so if you are doing these roll-up cube and so on, things like that, you still need to list them all out explicitly. Okay. Alrighty then. Let's go back to inserts briefly. And while we do that, someone's saying, do any of these insert statements come with performance costs over the existing insert methods? Not that I'm aware of. I'm not aware of overheads particularly. I haven't tested them to kind of verify that, but this will be resolved at pass time. I think so. I'd be very surprised if there was any noticeable overhead or difference. But like I say, I haven't tested in any meaningful way, you know, but I would be surprised if there is. Right, let's go back to inserts. And we look at, I talked a bit about these IDs, and quite often they would be sequence generated. And, another debate is, well, rather than using sequences or numbers, you might use GUIDs or UUIDs, those big 32 character hex numbers, right, to identify things like that. So let's say rather than an employee ID, we want an employee GUID. Okay. So we can do that. We've been able to do that with employee, and we can do GUIDs as raws, so binary values. And sysGUID, again, is a function that's been around for as long as I can remember, very long time, which can generate these generate these unique identifiers. And we select them. We see they're not that random, really. They all look kind of the same here. You stare at this, you're like, what's changed here? I can't tell what's changed. If I scroll up and down a tiny bit, we might be able to see it's this character kind of in the middle somewhere that's changed each one. So particularly when we run it within a session, these values are almost all identical. So this has a couple of problems. First up, some might lead to kind of index contention and things like that. You might want random values to kind of make sure the values are spread throughout an index. Whether you want that is, it's a debate for another day, but you might want to do that. But another thing to bear in mind is there is an RFC for unique identifiers, like a standard. I'm not sure it's really a standard, but there is a RFC which documents different types of unique identifiers that are available, these GUIDs or UUIDs available. SysGUID is an Oracle algorithm which is different to all of these these RFC ones. So if you need, maybe you work in some environment where auditors say you've got to generate unique identifiers which comply with this. And I was like, oh, you can't use SysGUID. Okay. So UUID, new function in 23.9, which is compliant with this RFC, and it's version 4 compliant. If you ever want to go down a bit of a rabbit hole, read this RFC. There's 7 different versions. I think it's 7. There might even be 8, actually. There's loads of different versions for these unique identifiers. Thing here is UUID are random ones, and they are compliant with that. So I can notice I've run the update and we do it. Now you can see the values here are completely random. So if you want random values for these identifiers, we can use this UUID function to do that. So just to kind of compare UID versus sysGUID, we'll compare them. I'm also just doing it to a regular string of alphanumeric values just to show. We've got a couple of new functions, raw to GUID. So both of these return raw values, so binary values. So we use the new function to convert so hard to say this multiple times, UIDs to strings, to character values, or raw to hex to convert the sysGUIDs. And the isUUID verifies that not that the 32 character hex codes, it's that they are compliant with that algorithm. So you notice only the v4 UIDs are true, the others are false. Okay, unsurprisingly, the string is false because they're not hex values, but also sysGUID is false because it doesn't conform to that algorithm. Okay. There is a parameter you can use for this. You can put in nothing, which defaults to 4, or you can put in 0, which also means 4, obviously. We don't support other version numbers at this point, but maybe we'll be able to add them at some point. So we can do this, generate these UUIDs, and we notice the raw to UUID doesn't just turn it into a string value, it also does some formatting of it as well, puts these kind of little hyphens in at specific points here. And this, you can see what makes it a version 4 is they've all got a 4 at this point in the string. They're completely random, or more or less as random as you can get, except for they've all got a 4 in this position there, here. Okay. So we can use that and just show it is a raw value. Those of you know your type numbers, 23 means raw. Look it up in the docs, right? We all know these, right? No, nobody knows what these are. But the key difference is the raw value is 16 bytes, whereas the string value is 32 characters. So at least 32 bytes, maybe a bit more if we've got these hyphens in there. So the raw is more compact and therefore more efficient to store and things like that. Okay, so you got, well, that's great. We've got these UUIDs and they're completely random, but what if we want like other forms of UUID? Like version 7 actually has kind of ordered in some way. Again, you look it up if you want to know the details. If we want to, what if we want to generate those in the database? Well, one way we could do that is with JavaScript. All right, there are JavaScript libraries out there which do this logic for you, so you don't have to do it. There is this a library I've found, an open source UUID v7.js. Like say, this is just a demo. If you do want to use this in your real production systems, make sure you check your licensing and, you know, are you okay to use open source and so on. But just to show, we can download it and then load it into the database using this MLE command in Oracle SQL CL. I've already, here's one I've done earlier. I've already loaded these in into the database. So I've got our v7, can expose it by making an MLE module. Again, so this MLE stuff is new functionality in 23 AI. This allows us to expose that as a function, and I've already done that. And we can see we can now generate these values. And these, notice here we've got a 7 in this position of the UID, and they are kind of sequential, right? I forget the exact rules for it, but it's based on like the timestamp and something like that, I believe. All right. So while we're talking about JavaScript, there are a few little tweaks. One is, they say, there are fewer permissions we need. In the past, or when this was first introduced, you had to do something like this, you had to have the grant execute on JavaScript privilege. Yeah, had to do that to be able to do these things, to run JavaScript store procedures. This privilege is no longer necessary. Notice I do not have that privilege, right? I've got some other inherent privilege, but I don't have execute on JavaScript. The other thing is we've got some validation here. I've got a little JavaScript thing to convert dates to epochs. There is no epoch native function in Oracle database, so I've decided to JavaScript it for whatever reason. But I've got a problem. It won't compile, and it's a syntax error. So we've got better syntax compile time errors with JavaScript. What's my syntax error here? Expected semicolon, but found date constant new date. Okay, you know, I'm not a JavaScript guy. I'm not sure how many of you are, but I've screwed up my new here. I missed out the E, right? If we fix that syntax and run it again, we should find this now works. There we go. We compile that and we can see we've got our epoch. And so we'll see this counting the seconds of our life tick away as time goes by. So we got that to do that. Alrighty, any questions or comments on that? So yeah, question on Emily available in 23 AI free. Yep, this is all, I mean, like I say, I'm running the demos on my always free autonomous database. It also works on the Oracle database free that you can download and install for yourself. It's the same functionality everywhere. Okay, so yes, you can do exactly what I've done on 23.9 of Oracle database free if you download it and install it. So if you use identity and primary key in the DDL, how can you use any of the generators except the sequence? I'm not sure what your question is there. I mean, do you mean like as a default for the table? I'm not quite sure what your question is for the UUID. If you clarify, that would help. Um, with sets, oh yeah, going back to insert set, does it work in PL/SQL? Yes, it works in PL/SQL. Let's see if I can find it. I can wrap it in. There we go. Let's just wrap this in PL/SQL. There we go. That will work. Boom, that works. Right. So yeah, the syntax is supported in PL/SQL. It should work with for all and things like that. Like it should work everywhere. Everywhere this you've got an insert, you can use this. You should be able to use this new syntax as well. Okay. All right. Any other questions or comments before we wrap up? Okay. So I'm not quite sure what you're asking about using the identity and primary key in the DDL. If you could clarify that, I can answer. All right. Okay, so let's just recap these. These are the little tweaks in 23.9. So first up, group by all. So everything you in the select statement, all the columns which are not part of not used in an aggregate function, so count, sum, min, list ag, so on and so forth, they will automatically get copied to the group by clause, and it's on their alias, or the result of the expression, the function, right? It's not the raw column; it's actually what you selected, rather than the underlying column value. So you preserve formatting and things like that. If you want to generate unique values, so we got still losing the ability to say this, the UUID function, and it's version 4 compliant. There is a parameter for that, so maybe in one day in the future we'll have support for other UUID formats as well. And then we just saw some little tweaks for JavaScript in the database. We've got better kind of compile time checking error messages so you can see what's happening. And we've simplified the privileges slightly just to make it a little bit easier to get up started and up and running. So I'm not seeing any other questions or comments. So just a reminder, if you like puzzles, like games, want to practice your SQL skills, check out Speed SQL. It's like a race against the clock. 60 seconds, 10 statements, guess the missing keyword. Can you get them all? Get them all on first try as well. That's probably the more interesting thing. We've also got SQL Wordle, which we're calling Squizzle. It's our daily guess the SQL statement quiz. So both of these on Oracle Dev Gym, new Squizzle, new Speed SQL, set of Speed SQL statements released every day. Come back, practice your skills, hopefully have some fun whilst doing so. With that, I'll just to wrap up, I'll say a couple of months ago, we had Rick Van Dyke join me to talk about plans. It seemed to be a very popular session, lots of people enjoying that and lots of interactivity. So I invited Rick back, so he'll be joining me next month to talk more about plans and his experience. He's a very knowledgeable, experienced guy working with Oracle performance. So that will be live Tuesday, the 21st of October, 2 p.m. London time. So all that's left to say is really hope you enjoy this. More importantly, I hope you learn something, and I will see you next time. Goodbye.